Hello and welcome. The main goal of this video is to add the selection sort algorithm to our single linked list, okay? And for that I will do the function getSize, getElementAtIndex, and finally the selection sort itself. Okay, and I will do the sort by age. After that I will do a demonstration of the code running. Okay, so the first function, getTheSize. Here in the code we just have to declare the int getSize that receives a node t pointer, that is our list, and inside we will declare an integer that is the result and is equals to 0, and finally return the result. In the middle we want to count how many elements we have in our list, so we do a while list is different from null and list next is different from null. Inside of our while loop we say that the result is ++, we increment the result, and then we update the list, the pointer to the next element. So list is equals to list next. Our first challenge is done, getSize. Now is time to do the getElementAtIndex. In the code we have a getElementAt, and this function will return a node t pointer, and it will receive a node t pointer that is our list, the head of our list, and an integer idx that is our index, the index that we want. Here in the code we say we declare first the node t pointer result that is equals to null in the beginning, and after everything we just return the result. In the middle we have to declare an integer that is the counter for finding the index, and we have to iterate over the list using a while list is different from null, and also the list next is different from null. We have to do inside update to the pointer of the list, so list is equals to list next, okay, and then we check if we found the desired element, so we check if the counter is equals to the index that we want to find, and if it is equals we have to update the result with the list, the pointer to that element, okay, and after that we have to break the loop, the while loop. One more thing to do here is to update the counter. So we receive a list, a head, okay, and we will iterate over that list, and we have to update to the next element every time that we do the loop, okay, and we check if we found the index we wanted. If not, we just update the counter. If we found, we update the result with our element, the list, and then we break the while loop. After that we just return. Is just that. The second challenge is done, getElementAtIndex. Now it's time to do the selection sort itself, and we will sort by the age, okay? So let's do that. So the selection sort function is just a function that returns nothing and receives a node t pointer that is our list, the list that we want to sort. So in the code we say we declare an integer that is the size, and we call the first function that we made the getSize function, and we provide the list to that function, and after that we have to iterate over the list, and we will use a for loop. We declare an integer I is equals to 0 while I is less than size minus 1, because we want to iterate over all elements but the last one, okay, and we say that I is ++, we increment the I variable. Because these are a list and not an array, we have to get the elements itself, because we don't have a way to access them by indexing, okay, so like we do in arrays. So we have to declare a node t pointer that is the element at index I, so I will call it ILM, and get element at lists and the index I. So I'm calling the last function that we did, the get element at, and I provide the list and the I, the integer I, that is the index I. Okay, after that we declare another node t pointer that is our min element. I just call it min, and I say that it is equals to ILM. And we need another element, node t pointer, that is the JLM, the element at J index. So JLM in the beginning is equals to ILM next, just that. After this we have another loop, and I will use a while loop, and while JLM is different from null, and remember I'm using a while loop in this way because we have a list, not an array, okay? And inside of this while loop we have to check, we do the check for the age, we are sorting by age. So if JLM data age is less than min data age, we want to update the min element with the j element. So min is equals to JLM, just that. After this we have to update the j element to iterate over the entire list. Okay, so we say JLM is equals to JLM next, just that. After all of this we have to swap the I element with the min element, okay? And remember, if you saw the last video, I have a function here. I have this function that receives a list and receives an ID and a second ID. I will not explain this function here because I just do that in the last video. You can check that, and it's just that. I will call this function. Okay, so going back to our code, I have to call the swap function, and I provide the list and also the ILM data ID, because I want to give the ID of ILM, and min data ID too. So I provide the ID of ILM and the ID of min LM, okay? And I do a swap, just that. So we just did the selection sort algorithm, sorting by age, and now it's time to show this working. So here in the code we have the main function. I just changed a little, I commented a lot of code. Okay, I just want to test this thing, and I create a list that with the new node, and then I add last these elements: Peter with 14 years, John with 5 years, Lucille with 9, Ben with 3, Razia with 1, Luca with 15, Rebecca with 12, and Victor with 8. Okay, after that I just print the list, okay, and before sort, then I call the selection sort function and I provide the list, and then I will print after sorting. Okay, so here in the REPL I just pass the code, okay, and just for you to see that is the code that I just showed you, and I run this and we get this result. Before sort we have these: Peter with age 14, 5, 9, 3, 1, 15, 12 and 8. Okay, and after sort we have 1, 3, 5, 8, 9, 12, 14 and 15. Okay, so everything is working. So this is the end, and as always, thank you for watching.